Welcome to part 6 of Algorand for Visual Studio. In this video, we will get a quick overview of what smart contracts are on Algorand. We have already seen what Algorand accounts and addresses are. Recall that an account is identified by an address, and that address corresponds to a 32-byte number, usually the public key. As well as balances, the Algorand distributed database also allows these accounts to be associated with a program. In this case, the address is not a public key, but a 32-byte hash of an application ID. In this case, the account is called an application account. Using the .NET SDK, you can make an application by specifying its variables and code and calling an application create transaction. This returns the application ID, from which you can get the account address. Using subsequent transactions as explained in other videos, you can then send algo and assets to that account, giving the program control over those funds. This is why the applications are sometimes referred to as smart contracts. In later videos, we will see code being created and deployed to an account. In Algorand for Visual Studio, this code is authored in C# but is compiled to a machine language, called Teal, that the Algorand node can execute. Once the code is deployed, other users of Algorand may call the application using application call transactions. An important aspect of smart contracts is that they can be associated with three types of storage: global, local, and boxes. These apps can declare variables that are designated to one of those storage areas. Please see the Algorand developer documentation for technical limitations on storage sizes. Each type of storage is assigned to a different account. Globals are stored in the creator account. Locals are stored in the caller accounts. And boxes are stored in the application account. Anytime any account allocates storage, an economic disincentive is incurred, which is that the minimum algo balance for that account is raised. The key implication to realize is that because local variables are stored in the caller's account, the caller must call an opt-in transaction to that application to raise their minimum balance and have the local storage allocated. Calling an application does not automatically declare the variable on the caller account, because storage costs money, in that sense. However, the need to opt in only applies if a particular call to that application involves a local storage variable. A good example of the above is to imagine the smart contract is a commodity supplier contract. A global variable may be the public price of a commodity, while the local variable may be the discounted price for each customer opted into that contract. So in summary, an Algorand smart contract, otherwise known as an application, can be made by a creator account, which returns an application identifier, which gives the address of a special account for that application. That account can be given funds and assets, which the application can govern. The program can declare variable in its own scope, in a global scope, or locally to each user who wants to use it. In later videos, we will see how these apps are created, deployed, and used. Thank you for watching.